There is only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Binary Memory. So this is the way the module looks. It looks similar to the vanilla module of memory, but one of the key differences is that these numbers will always be ordered in exactly 1, 2, 3, 4. This of course is not the exact difference that we're looking for, but the background is dark. And it is going to have a display that will represent the stage counter, which will be colored either green or red. And this is going to be essentially, this is a boss. So what we're going to essentially be doing with this is we're going to be noting down not the values of the displays, but rather the colors of them, and the colors of them are going to be used essentially as binary. So in this case, as you can already tell, for those of you who are familiar with binary, green is going to represent 1, and red is going to represent 0, because it's only going to be appearing in these two colors, red or green. So for our first stage, we're going to record a 0, and that's all we simply need to record for this stage, and it's fairly simple. So there obviously is a bunch of this manual that is not really all that relevant. The main area that you're going to want to focus on is going to be this third LED in submit mode. The first LED, if there's only one lit LED, it's going to be in reading mode. This is essentially where we're looking at the boss and getting the stages itself. 2 LEDs is going to be ready mode. 3 LEDs is going to be submit mode. 4 LEDs recovery mode, and finally 5 lit LEDs module is solved, and congratulations. So that's all we're going to be doing here. Now, there is obviously some important things that we need to go over before we get into this. So this is the initial mode of the module. In this case, as you can see, we can start with 1 lit LED. The screen will show the number 1, and each time another non-ignored module is solved, the number will increase by 1. Okay, so we don't have to worry about recording the number that is present, but we need to record down the color, or in this case, the bit, in this case. And this number is the stage number. And the displayed number can be one of 2 colors, red or green. And this color is the value of the current stage, 1 or 0. Memorize the values, or simply write them down, of each stage. And if the values of 4 stages in a row match, press any button to enter submit mode. This is very important for this module, because it can potentially be solved earlier on. If at any point 4 stages happen to have the exact same color in a row, the module is ready to be submitted after that stage. Now, you want to submit during that stage, keep that in mind. But essentially, if you wanted to get this thing going, you must make sure that you have to enter into submit mode before any other non-ignored module is solved. You have to enter it when it hits that point, not after, but before. So otherwise, you will get a strike, and the module will enter into ready mode, which in this case, ready mode is going to be the two lit LEDs here. However, if it happens to go throughout the entire bomb, where all the non-ignored modules are solved, or stage number equals 45, then the module will enter into the ready mode. So there is a capping of this actual boss here. It's very important to note down. So there is going to be the 2 lit LEDs, which is going to be the ready mode. All we simply need to do is the value of the last stage. The value of the last stage is displayed on the screen. We're going to press any button to enter into submit mode. Note that this can happen. Note that this will only happen if you happen to get to the end of the entire bomb, and you haven't gotten the 4 stages in a row match, or you haven't gotten the 45. And what we're going to do is we're going to press any button to enter into submit mode. That's very important. So you will need to press any button in order to enter into submit mode. So let's actually go through this entire module, and let's actually get all of our stages that we need to, and then we'll look at submit mode, because this is the whole part of this module that is going to make this actually a little bit tricky to understand. It's a bit tricky, and I struggled with it myself. So let's get right into this. So we're gonna note down 0, which we've already done. We're gonna note down 0 again. We're gonna note down 0 again. And we happen to get exactly 4 stages in a row. So now, what we happen to have here is we happen to have this 4 stages in a row match, which in this case represents all 4 of these being zeros. In this case, I'm glad I was able to show this off. I would prefer to get a different example in the next stage, but keep following along with this. This is very important that you guys understand this. So let's get right into this. So this obviously can happen, but now what we have to do is we now have to enter into submit mode. And in this case, we just simply need to press any button. And what this will do is, as you can see, the LEDs will change, and now the screen will change itself as well. And what this means is that we're in submit mode. And what this means is that also the screen will turn to a sort of whitish gray color. And now what we need to do is we need to use these four numbers here in order to enter into submit mode. Now, as you can see here, what we have here is a large table, and we have a little bit of explaining that we need to do for the submit mode. Obviously, recovery mode is exactly what you think it is. It's recovery mode. I'm going to go over this actually real quick. When entering this mode, the screen will show the value of the current stage, and when any button is pressed, the screen will show the value of the stage for which this button was successfully pressed the last time. And if the button has not yet been successfully pressed, the number on the screen will be colored gray. When the same button is pressed twice in a row, the screen will show the value of the current stage, and when the same button is pressed 3 times in a row, the module will enter into submit mode. So that's what you need to do in order to get back into the submission mode when you're done with recovery, is essentially you need to look at the same button. You need to press that 3 times in a row, and it will enter submission mode. It's fairly simple. Hopefully you guys will not have to use that after you understand this module, and let's get right into what we have to do here. So first things first, we need to actually determine what our conditions are. First things first, is we need to determine we need to look at the columns and the rows, and we need to understand what we need from this. So for our columns, it represents the last digit of the stage number. So we're actually going to be using different columns each and every single time because of the fact that we're going to be entering in different digits. It's going to be the first stage, then the second stage, then the third stage, and so on and so forth. So that's the way that we're going to use this. However, the condition on the rows here is always going to be the exact same. It's always going to be the exact same because if we look, there are edge row conditions that apply here. So now let's take a look at our first one from top to bottom. So do we have port plates being greater than 2? And in this case, we actually do happen to have 4 plates greater than 2. We've got 1, 2, and 3. So this means that we're going to be looking at this row. And now what we're going to do is we're going to go column by column, and we're going to take a look at each of these individual numbers. So using the table below, we're going to prioritize the buttons for each stage. And to solve the module, press the valid button with the highest priority for each stage. And if the button has not been pressed before, then it is valid. Otherwise, the button is valid if the last press for that stage was with the opposite value. I will get into what that means during the second example because this is a very important concept to understand. However, what you can see here now is if all buttons are invalid, then the button is valid as 1. The current stage is displayed on the screen. So now, what we're going to do is we're going to go column here, and what we're going to take a look at is we're going to take a look at the first number on the left. Now, has this button been pressed before? In this case, it hasn't, so we can press 1 for this stage. Now we're going to go to stage 2. 4 is our first number here in this order. Has it been pressed before? No, it is not. So now we can do 4 for that stage. Next up, 3. At stage 3, 4 is the first one here. However, 4 has been previously pressed beforehand. Now what we want to do is we want to check if the button has been if the button has been pressed in the opposite value. It is not in this case. The opposite value would represent 1, so this is not true. Next up is 2 though. So 2 is going to be what we're going to do next because that has not been pressed yet. And finally for number 4, 3 has not been pressed yet. And as you can see, this is kind of where the thing arises with the whole 4 stages matching in a row. Because what you can have here is you can have all the numbers be pressed at some point. But essentially this is the way how you solve the module. So now, all we simply need to do is we need to input these 4 numbers in place. 1, 4, 2, 3.
Is the right answer.
And just like that is a solved module. The 5 LEDs light up. The module gives you GG. And just like that, you are done. So now let's go into another example, and I hope that I can get a bit of a different one because I want to show off exactly what makes this module so tricky. So let's get right into this, and hopefully a bit of a longer one too. All right, so we start off with 1. We get another one. Okay, we get a 0. Okay, good. This is already looking a lot better here. 0, 0. Okay, please. Okay, 1. Okay. 1, 0. 1, come on, 1, and 0. Okay, so now, what you can see here now is that we've solved all of the non-ignored modules, and it's gone into the 2 LED mode. So now we're in ready mode, and all we simply need to do is we need to simply hit the button, any button on the screen here, any button here. So let's do that. And now, let's continue with our submit mode. This is going to be a bit of an interesting example, and I'm glad I'm able to teach this because this is going to be a very good one to use. So let's take a look. So we do not have port plates greater than 2. That's not true. Serial number letters equals 3. It does not. It's equal to 4. Battery holders is equal to 1. Definitely not. There's more than 1 there. At least 29 modules. No, we only have 11 present on this bottom. So we're gonna hit the otherwise condition, and we're gonna take a look at here. So now, we're going to do what we normally did. So, we're going to start with the last digit of the stage number. In this case, it is 1. And what we're going to now do is we're going to take a look at these things here. So, 1. Has it been pressed before? No. We can use that. Next up, 2. The first one we get is 4. Has that been pressed yet? No, it is not. Next up, last digit of the stage number is number 3. And now we're going to get into some opposite values here. So now, let's take a look. For 3, the first one gives us a 3. Has this been pressed yet? No, it is not, so we can use 3 here. Number 4. Now here's where things get interesting. So, if the button has not been pressed before, then it is valid. 1 has been pressed before. Otherwise, the button is valid if the last press was for the stage with the opposite value. And in this example, the last time we pressed 1 was when the binary bit was 1, and we are currently on a 0 right now. So now, what we can actually do here is we can press 1 in this instance, and this is going to be our answer for that stage. This is the way how this works. Okay, let's continue on. Next up, we're on the 5th stage here. So this is going to be, the first one is going to be a 2. 2 has not been pressed yet, so we can press that. And now let's head on over to stage 6. Now, again, this is the exact same example that we just had beforehand. 2 is our first number. 2 was previously pressed beforehand. It has been pressed. In fact, all of the buttons have now been pressed. Now what we want to do is we want to pay attention to if the button was pressed with the opposite value. And in this example, 2 was indeed pressed with the opposite value, because we're currently on a 1 right now, and the last time 2 was pressed was on a 0 with that value. So 2 is able to be pressed here. Moving on to stage 7, same case with 1. 1 was pressed in the previous value of 0, and we're on a 1 in this case, the opposite value, so we can press 1 here. Okay, moving on to stage 8. Same case as this one. 1 was pressed when it was a 1. We're currently on a 0. We can press 1 here. Now, next up, this is going to be a 1. Now, 4. 4 cannot work here because of the fact that the last time 4 was pressed was when it was a 1. And it has been pressed beforehand, and it is not of the opposite value. So this does not work. So this means that we cannot do this. Next up, 2. 2 was pressed when it was a 1, not going to work. Now, 1 was pressed when it was a 0, so we can press 1 here. And essentially, if you happen to go through all of the individual buttons, and if all buttons are invalid, then you will press 1 by default. In this case, you want to go from left to right. We got to the third number. In this case, 1 was valid. Next up, 3. 3 was pressed when it was a 0, and we're currently on a 1. This is the opposite value. We can press 3. And finally, going back to stage 11 here, because this is going to be the last digit of the stage number, 11. And now let's take a look. 1 was pressed when it was a 1. We're currently on a 0. That was the last press there. This is a 1. And now we're going to input all of these guys into here. So we got 1, 4, 3, 1, 2, 2, 1, 1, 1, and then 3, 1. And just like that is a solved module. I want to go over one more example of this because it's very important that I cannot stress enough how this makes sense, and I hope I'm explaining this in a good way. But the way that this works, and instead of it being just ones all throughout the entire module, is you want to pay attention to each individual number when it was pressed, when the last time it was pressed, and under what value and what value you currently are now. That's going to be very important for you to pay attention to. So let's take a look at one more example, because I want to be able to get hopefully not one that is not 4 stages in a row, and I want to be able to get some conditions that we can use here. This is one that I definitely want to cover in detail because it is a module that has stumped me up beforehand, and I hope it's not going to stump you guys up. That's my plan here. So, okay, so let's go into one more example here, and let's get this thing done. Yep. We've got 0. We've got 1. We've got 0. We have 0. We've got 1. Okay, good. Mixing it up. 1, 1, and 1. Okay, so now we actually did get some mixing up here, but we now have 4 1s in a row. So in this case, we're going to enter into submission mode here. We do not want to solve anything else before we get into submission mode. We can solve the rest of this bomb here now freely because it's now in submission mode, and we do not care about the rest of it. So let's take a look here. So now, first things first, let's determine what our condition is here. Do we have more than 2 port plates? We do not. Serial number has 3 letters. Does it? It does indeed. Yes, it actually does. Victor, India, Golf. This is going to be our row. Perfect. So now let's start with this thing. Usually for the first stage, you're going to start with the first number. Actually, you are going to start with the first number regardless of what you get. So we get 3 for this first one here. Next up, 2. Now, taking a look immediately, our first number is 3. It has been pressed before, but the last press was of the opposite value that we are currently on now. 3 is able to be pressed here. Now, for this next one, 3, stage 3, we have not pressed 2 yet, so we can press that one. We have pressed 3, but it was of the opposite value once again, so we can press 3 here. 4 has not been pressed yet. 6, 2 has been pressed, but it was of the opposite value. We can press 2. 1 has not been pressed. And finally, 2. 2 was used of the same value. That was our last press, so we've already pressed that, and we're currently on the same value as the last press of 2. 3. Now, 3 was pressed. It hasn't been pressed beforehand, but the last press was the 0. So in this case, it was on the opposite value. So our last value that we can press here is going to be a 3. Just like that. There we go. So now let's input this. We've got 3, 3, 2, 3, 4, 2, 1, 3. And just like that is a solved module. A fairly simple concept, but just make sure that you always think in your head, hey, has it been pressed before? And once you get past the point where all of them kind of have been pressed, in this case, once you get to that one, all you simply need to ask yourself now is, has this number been pressed of the opposite value based off of the last press? Make sure you base it off of the last press, of the most recent press of 3, for example. Don't compare it to this 1 over here. Don't compare it to this 0 over here, even though that's relevant. Compare it to the most previous press. So, just like that, there we are. And as always, thank you guys for watching. Remember to stay crazy, stay cool, and I will see you guys in the next one. Bye-bye.